Have you ever looked up at the night sky? You see countless stars twinkling back at you. Each star is a sun, just like our own. Many of those suns probably have planets circling them. It's a vast and beautiful sight. This sight makes you wonder about big questions. Is there anyone else out there? Are we the only thinking beings in this enormous cosmic ocean? This is a question that humans have asked for thousands of years. It has filled our stories, our myths, and our dreams. It is a question that sits at the very heart of what it means to be human and to be curious about our place in the cosmos. This question of being alone is not just about aliens on other planets. Modern science has pushed this question even further. It asks something even bigger, something more mind-bending. What if our entire universe is not the only one? What if there are other universes out there, separate from ours? Imagine countless bubbles floating in an endless space. Our universe is just one of those bubbles. Before we can talk about other universes, we need to be clear about our own. What exactly is a universe? In the simplest terms, our universe is everything. It is all of space, all of time, and everything that exists within them. This includes all the matter you can see, like stars, planets, and galaxies. It also includes all the energy, like light and heat. Because the universe is 13.8 billion years old, there is a limit to how far we can see. Light from very distant objects has been traveling towards us since the universe began. Any object further away than 13.8 billion light years has not had enough time for its light to reach us yet. But what lies beyond this horizon? The most straightforward answer is simply more universe, more galaxies, more stars, and more empty space, looking much like the part we can see. One of the leading theories is called eternal inflation. This theory suggests that the Big Bang that created our universe was not a unique event. Instead, the process of cosmic inflation might be happening all the time in some larger metaspace, constantly spawning new bubble universes. Our universe would be just one of these bubbles in an endless, frothing cosmic foam. Another path to the multiverse comes from the weirdness of the very small. This idea emerges from quantum mechanics. The many worlds interpretation suggests that every time a quantum measurement is made, the universe itself splits into multiple branches. This creates an infinitely branching tree of realities, with countless parallel versions of you being created right now. String theory provides another path to the multiverse. It predicts a vast landscape of possible universes, perhaps as many as 10 to the power of 500. Each universe could have different physical laws. Some might collapse immediately, others might never form stars, and ours happens to have just the right conditions for complexity and life. How could we ever prove such a wild idea? Scientists have to be clever, looking for indirect evidence, faint whispers or echoes from other worlds. One promising place to look is in the cosmic microwave background, the leftover heat from the Big Bang. It's like the universe's baby picture. If our universe bumped into another universe long ago, it might have left a cosmic bruise, a circular pattern in the CMB that would be incredible evidence of the multiverse. Another way to search is through particle physics. Giant machines like the Large Hadron Collider smash particles together at incredible speeds. If energy mysteriously disappears from an experiment, it could be leaking into other dimensions that might connect to other universes. So far, no such missing energy has been detected, but future, more powerful accelerators might probe these exotic realms. The greatest challenge in proving the multiverse is perhaps the most obvious one. By definition, another universe is separate from ours. We are fundamentally trapped within our own cosmos. We cannot build a spaceship, punch in coordinates for Universe B, and go for a visit. All our observations and experiments are limited to our own universe. We can search for indirect evidence, but these are just shadows on the wall of our cave. We're trying to deduce a vast forest by seeing a single oddly shaped leaf. Science relies on observation and experimentation, but how can we test a theory about a place we can never access? This creates a debate about falsifiability. Many critics argue that multiverse theories may not be true science at all if they cannot be tested. The debate raises a crucial question. What are the rules of science when the object of study is reality itself? Today, the search has moved into observational cosmology, led by a new generation of cosmic detectives working together to analyze vast data sets. They spend years developing complex algorithms designed to search for predicted patterns, patiently sifting through ancient light for the faintest clues. Promising signals occasionally emerge, sparking excitement, but so far none have survived intense statistical scrutiny. With each new generation of telescopes, our view becomes clearer, and our ability to test these radical ideas improves. Future particle accelerators might reach energies high enough to see effects from extra dimensions or detect missing energy. We may yet find that definitive circular scar in the cosmic microwave background, or see energy vanish into another dimension. Why does this search matter so much? Beyond theoretical physics, the question of the multiverse touches something deeply human. It's the ultimate extension of the question that has haunted us since we first looked up at the stars. Are we alone? Finding an answer would be the final step in the Copernican revolution, moving us from the center of everything to just one of countless cosmic possibilities. Discovering the multiverse could foster cosmic humility, showing that our universe is not necessarily special, while offering a sense of connection to a vast creative process. Knowledge of countless other worlds could inspire new forms of art, philosophy, and storytelling for generations to come. It would fundamentally change the context of human existence, expanding our horizons in the most dramatic way imaginable. Even if we never find definitive proof, the act of searching changes us. It forces us to think bigger and appreciate the mystery of our known universe. The quest keeps the spirit of discovery alive, encouraging bold questions and celebrating the human mind's ability to grapple with concepts far larger than itself. Ultimately, the search for other universes is a search for ourselves, an attempt to understand reality and our role within it. The mystery of the multiverse will continue to call to us from across the void.